Hello everyone, this is Shesha Prasad and I am hereby presenting a topic of data structure and algorithms, and in that I am going to do the operations on that can be performed on a linked list. I'm just going to explain the basic operations like insert front, delete front, and display the contents of the linked list in this video. I have written the code beforehand so that it is easy to explain. So let's start. The first one is inserting at front end. Here there is always a first pointer which is always assigned to null, and then this is a menu driven program, so this is the menu where insert, delete, and display, and user has to enter a choice which is read by scanf, and the choice is read by scanf, and it is put under a switch statement. So case 1 is first is equal to, which is this one, first is equal to insert of first, and you might think, what is this node? This is user defined data type. Here it is struct node, which is a struct node. There we have declared a structure called node, and int info for the info field, and struct node star link for the linked field. And I have type defined it to struct node star node in capital letters. That means wherever I write node in caps, it refers to the struct node star. So this is a user defined data type. So I will be creating a function first for creating a node. That is of the return type is same, user defined node, which we have created. Create node function. Node of x is a variable created. X is, and we are assigning it in memory using dynamic memory allocation, so that I will be using malloc. X is equal to, this is the typecasting node, malloc size of struct node, because we need the size of the structure which we have declared here. And I will be returning the address after dynamically creating the memory. So we'll come to the first function, which is insert front. Here I will be creating node temp variable, and then element for storing the element in the info field, int element. Temp is equal to create node. Here in the create node function, we have the address that is returned by the malloc function, but for unsuccessful memory allocation in malloc, we need to check for if there is an unsuccessful memory allocation. So we need to check if temp is equal to null, printf unsuccessful memory. That is, if there is no memory allocated, malloc will return null value. So we need to check that. But generally in higher order system, there is always memory allocated. So we'll directly go to printf statement. Printf enter the element to store, and we will read the element using scanf. Now the variable temp of info is equal to element. That is, in the info field of the temp, we are assigning the element, and the temp of link is equal to first. We are pointing the linked field of the temp variable to first, and first is equal to temp, and I am returning this address. That is, I am returning first to here. Here first is equal to null, and then we have created a node. Now this node has info field and linked field. Here we are assigning an element to the info field, and now we in the code it was written that temp of link is equal to first. Now here we have first is equal to null. So here the element will be stored in the in the info field, and the link field is pointing to first. Here we have null, so this will be null, and then first is equal to temp. So first will be pointing to this temp here. uh, now also I will take another example. When there are, this is an example for one node. Now when we have two nodes, here again, this is an element 1, you consider element 1, element 2, element 2. This is the linked field of first node and this is the linked field of second node. Now we'll go back to the code. Temp of info is equal to element and temp of link is equal to first. Here the first is pointing to node 1. Temp of link, this is the new node created, so temp of there it is said that temp of link is equal to first. Now here the first is pointing to node 1, so obviously the linked field will be pointing to, linked field is now pointing to first, so it will be pointing to node 1, and then first is equal to temp, so then now first will be pointing now to node 2 because it is the newly created node. This is the insert front function. I'll just run the VS Code for better understanding. Now we have enter your choice. I will show you the insert function. Enter the element to store. I'll give 1 and I will give 1 2 3 first to store. Now I will display it. See, now this is due to the front end insertion. So 3 is inserted first, 3 is shown first, and then 2 and then 1. Now let us come to deletion at the front end. Now again, when we are historically when we are inserting at the front, consider this is the first and this is node 1. When we are inserting at the front, it means that node 2 which is created will always be here inserted here in the front end. So it will look something like this. Now for deletion, we'll go to the code again. Node, that is user defined data. We have defined the data type. Node delete node first. Again we have created a variable temp. Now we need to check if the list is empty. So if first is equal to null, then the list will be empty. So write a printf statement saying list is empty. Now temp is equal to, we have returned an address here in the insert function, return first. So I will be assigning temp is equal to first, which contains all the details now. Now in a printf statement, I'll write the deleted element is %d temp of info. That is, we need to delete the info. The element is stored in the info field of a node. So the deleted element is %d because we have declared the element in integer. So %d temp of info. First is equal to temp of link. After deleting, we need to assign the linked field of the first to temp of link again, and we free the pointer temp and return the address. This is deleting at the front end. Now we have first node 2 and node 1 for deleting. First now this is the basic configuration. Now we will assign, because this is deleting at the front end, this node should be deleted first. The code is like temp is equal to first, and now printf the deleted element is %d. So whatever element is present here, after it will be deleted. First was pointing to node 2. Now temp of first is equal to temp of link field. The linked field is pointing to node 1. So the linked field is pointing to node 1. So now when we assign first is equal to temp of link, it will automatically point to node 1 like this. And when we use the free of temp, node 2 will be deleted. This is the delete function. Now again, deleting at front end is the same way. First element deleted is 3, second element deleted is 2, and third element is deleted is 1. And now there are no elements left in the linked list. So again, the printf statement should be like the linked list is empty. Yeah, list is empty. And now we have display. In the display function, whatever you have entered will be, whatever you have data you have entered in the info field will be displayed. For display, the return type is void, and here also we return the address. We give the return. We pass the address of the first, and again I'll create a variable temp, not temp. Temp is equal, and assign temp is equal to first. Now if first is equal to null, the linked list is empty again. So we write a printf statement for that. Otherwise, else printf the linked list elements are while temp not equal to null. That is, whatever you have created now, temp, the variable temp, and you have given it to first, until and unless the linked field is not equal to null, you need to print the elements. So we use a while loop. Printf %d temp of info. The printf %d temp of info. Temp is equal to temp of link. That is, you print the info field, and using the link field you point to the next node, which again gives the which again has the info field, and that element will be printed. So this is all about display function. There are no elements left in the linked list. So again, the printf statement should be like the linked list is empty. Yeah, list is empty. So this is all about linked list, and there is no overflow linked list because we are creating the memory dynamically. So however, again we are using dynamic memory allocation, so n number of nodes can be created using this. So this is all about operations on linked list. I hope you have no doubts. Thank you.